Good afternoon. Okay, so in the last class we discussed the problems comes under uh, type 5. So type 5 is the right hand side of the differential equation is polynomial in x into sin ax or polynomial in x into cos ax. So now type 7 problem, sorry, type 6. Yesterday we discussed type 5. Now type 6. So type 6 is the right hand side of the differential equation is polynomial in x or algebraic function. Please write algebraic function into exponential function e power ax into sin ax, either sin ax or cos ax. So this is type number 6. So that means you know that type 4 is e power ax into e power ax into v of x. V of x is either sin ax or cos ax or algebraic function. In type 5, we have algebraic function into sin ax or algebraic function into cos ax. Now all the possible three combination, that is algebraic function, exponential, sin ax, or algebraic function or exponential or cos ax. So this is type number 6. So directly I go to the problem. Solve d square minus 2d plus 1 to y equal to x into e power x into sin x. Okay. I think here we have algebraic function, exponential, and the sin ax. So solution. The auxiliary equation is m square minus 2m plus 1 equal to 0, or m minus 1 whole square equal to 0. So this implies m equal to 1 comma 1. Okay, the complementary function is equal to c1 plus c2 into x into e power x. Okay, now particular integral 1 by d square minus 2d plus 1, you can write d minus 1 whole square. Right hand side function is x into e power x into sin x. Okay, now first I am going to operate e power x. So e power x, that means you are replacing d by d plus a. A is here 1. D plus 1 minus 1 whole square into x into sin x. So now this is actually type number 5. This is type number 5. X into sin x. So this is equal to e power x 1 by d square x into sin x. So you can solve this problem in two different methods. One is you should integrate it twice because 1 by d square, and if you integrate twice, you can get the answer. Otherwise, this is type number 5. You should write sin x is equal to imaginary part of e power ix, and then you can proceed. Okay, imaginary part of x into imaginary part of e power ix, and then you should take imaginary part out, and then you should replace d by d plus I. You should replace d by d plus I. But here I'm not going to use this method. So you may do this method as a homework or practice problem. Okay. And now I'm going to integrate twice and get the answer. Okay. E power x into 1 by d square is double integral. Okay. E power x into 1 by d square, that is double integral. Double integral x into sin x dx. Okay. This is equation 1. Now I am going to integrate only first this part. So for this, I'm going to use integration, not integration with parts, Bernoulli's formula for integration, uv dx. Tell uv dx is what? U v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on. Okay, so you know that u double dash are derivatives, and v1 v2 are integration. Now we need to calculate x into sin x dx is equal to, okay, I will write directly. So this is actually u, this is u, this is v. So if you know how to apply this formula, you can tell to me. So any one of you? Otherwise, okay, first I will tell you u equal to x, v equal to sin x, u dash 1, u double dash is 0. If you integrate v, you will get minus cos x. If you integrate minus cos x, you will get minus sin x. So you should multiply u and v1, and u dash and v2, and u double dash and v3. Because u double dash is 0, I am not finding v3. Okay. Now integration x into sin x into dx. So to keep x as it is, even if you suppose you forgot this formula, don't worry. To keep x, if you integrate sin x, you'll get minus cos x. Alternately plus and minus, plus, and then here minus. Differentiate x, you'll get 1. Integrate minus cos x, you'll get minus sin x. So minus x cos x plus sin x. Now equation 1 implies the particular integral equal to e power x into integral integration of x sin x dx is what? X into minus x into cos x plus sin x into dx. Okay. Okay. Now I will write next page, which is equal to e power x into integration minus integral x into cos x dx and then plus integral sin x dx. So now e power x integral minus, okay, first I will tell you, okay, first we will calculate this one, integration x into cos x dx. So you can keep x as it is. If you integrate cos x, sin x, minus, if you differentiate x, you get 1. If you integrate sin x, you get minus cos x. Now e power x, here have minus sign, so minus x into sin x, minus into the 3 minus, so minus cos x. If you integrate sin x, you get minus cos x. So final answer is, to take minus commonly, minus e power x, x sin x plus 2 cos x. So this is pi. So y is equal to cf plus pa. Okay. So if you have any doubts in the first column, you can ask to me. Santosh, is it clear for you?
Sir, what happened to the d square in the denominator?
Uh, that's why I 1 by d square, okay, into f of x is equal to double integral dx dx.
Okay, sir, got it. Sir. Forgot, sorry,
Uh,
sir.
okay, it's okay. At least you are asking some question. Okay, I'm very happy. So if I ask some a question, or if I tell some name, the response is very important. So you can tell at least I don't know, sir. Okay. The second column, d square minus 4d plus 4 into y equal to 8x square e power 2x into sine 2x. Okay, the auxiliary equation is here. M square minus 4m plus 4 equal to 0. Okay, so you can write this is m minus 2 whole square equal to 0. M equal to 2 comma 2. So the complementary function is C1 plus C2x into e power 3x. The particular integral is 1 by d minus 2 whole square, d minus 2 whole square 8 x square e power 2x into sine 2x. So again, this is actually algebraic exponential sine ax. So first you should replace, you should operate e power ax. So e power ax means you should replace d by d plus a. A is here 2. Into x square into sine 2x. So again, this is actually type 5. So this is equal to e power ax 1 by d square Suppose if I have plus 1 or minus 1 or plus d or minus d, then you should write sine 2x is equal to imaginary part of e power I 2x and then proceed. That is the only possibilities. But here I have only d square, so I have the other possibility also. I can integrate again twice and get the answer. So try to solve the same problem uh, uh, as under the case type 5. That is, you should replace this imaginary part of e power I to x and then replace d by d plus 2I and then proceed and try to get the same answer. Not now, later.
Sir, 8x.
Okay, 8 mispelled. Thank
Yes.
you. Okay, I will write here. Okay, I will write better to write 8 here. Okay, thank you. So
Sir, why
8,
e power ax?
sorry, y,
E power ax.
okay, 2
Yeah.
okay, thank you. So now, e power ax சொல்லிட்டு 2 போல ஏற்படும். Okay. So now we should integrate this is twice 8 into e power 2x. Okay, 1 by d square. So integration twice x square sine 2x. So now I am going to check how you are very good in integration. Okay, so the basic integration is not a very big integration. Okay, you can also try, and if you don't know, just you can follow my procedure. Okay, and and if you have any doubts, you can ask. And if I done any mistake, please point out. First, I am going to calculate this one. I call this is equation 1. So integral x square into sine 2x dx. So the last problem I solved. Okay, same thing you should apply here, Bernoulli's formula. If any one of them knows how to write, you can tell.
Sir, minus x square cos 2x by 2.
Okay, your answer is correct. What is your name? Oh, Lakshmanan. Okay. So I am expecting you should tell like this: x square, okay, into, you should keep x square as it is. If you integrate sine 2x, you get what? Minus cos 2x by 2. So in this manner, if you tell, everybody will understand. So if you directly tell the final answer, maybe somebody don't know how it comes. So that's why I'm asking you. You should tell like this. Can you tell like this, Lakshminarayanan?
Okay, sir.
Okay. So first you should keep x square as it is. If you integrate sine 2x, you'll get minus cos 2x by 2. And the formula you have minus. Next,
2x sin 2x.
first 2x. Okay, பொறுமையாவே போகும். 2x. If you differentiate x square, you'll get 2x. Okay, if you integrate minus cos 2x by 2, including the minus sign, minus sine 2x by 2 into 2, 4. Okay, next to plus, if you differentiate 2x, you get 2. If you integrate minus sine 2x by 4, including the minus
Cos 2x
sign,
8.
plus, okay, plus cos 2x by 2 into 4, 8. Okay, thank you. So this is equal to 8 into e power 2x, 8 into, okay, integration. Okay, first I will simplify and then next step I will write. This is equal to minus x square into cos 2x by 2 plus x into sin 2x by 2, x into sin 2x by 2 plus cos 2x by 4. Now substitute this value here. Equation 1 implies pi equal to 8 into 8 into e power 2x integral minus x square cos 2x by 2 plus x into sin 2x by 2 plus cos 2x by 4 into dx. Okay, now I am going to keep e power 2x here, and I'm going to multiply by 8 minus 8 by 2 minus 4 integral x square into cos 2x dx plus 8 divided by 2 is 4 integral x into sin 2x plus 8 by 4, that is twice integral cos 2x into dx. I think here you can write dx. Here also I'll write dx. E power 2x is common to all the three integrals. Now I call this is equation number 2. Evaluate integral x square cos 2x dx first. X square cos 2x dx. So first you should keep x square as it is. If you integrate cos 2x, you get sin 2x minus, should keep x, I should differentiate x square, you get 2x. To integrate sine 2x by 2, you'll get minus cos 2x by 2 into 2, 4. And then plus, if you differentiate 2x, you'll get 2. If you integrate minus cos 2x by 4, you get minus sine 2x by 8. Okay, so now if you simplify, you get x square sine 2x by 2 plus x into cos 2x by 2 minus sine 2x by 4. Okay, this is actually integral x square into cos 2x dx. Okay. Similarly, find integral x into sine 2x dx. Integral x into sine 2x into dx. So x, if you integrate sine 2x, you get minus cos 2x by 2. Okay, minus 1 into minus sine 2x by 4. So you will get minus x into cos 2x by 2. Okay, and then plus sine 2x by 2x by 4. Okay, now equation 2 implies pi equal to e power ax e power 2x into minus 4 into integral x square cos 2x dx. So please tell these three expression, any one of them tell. The next page I will write. Okay, x square into sine 2x by 2 plus x cos 2x by 2 minus sine 2x by 4. X square sine 2x by 2 plus x cos 2x by 2 minus sine 2x by 4. Okay, and then plus 4 into these two terms, minus x cos 2x by 2 plus sine 2x by 4, plus 4 into minus x cos 2x by 2 plus sine 2x divided by 4, and then plus 2 into integral cos 2x dx. So if you integrate cos 2x, you'll get a sine 2x by 2. So plus 2 into sine 2x by 4. So now if you simplify, you get the answer e power 2x into minus 2 into x square into sine 2x plus okay, please write. plus, sorry, not plus, minus 4 by 2 is 2, x into cos 2x, minus into minus plus, 4 into 4 gets cancelled, sin 2x, minus 2 x cos 2x, plus sin 2x, plus sin 2x. So this is equal to e power 2x. So here minus 2 x square sin 2x minus 4x cos 2x, okay, 3 sin 2x. So the final answer is, you can stop here, otherwise if you want to try to one more step, uh, 3 minus 2x square into sin 2x, okay, minus 4x into cos 2x. This is actually t. So CF equal to, sorry, general solution is y equal to CF plus T. So any doubts in this problem? If you have any doubts, you can ask to me. Okay. Clear, sir. Okay, thank you, Maniranjan. Okay, now I am going to next type number 7. This is the last type in constant term, constant coefficient. So type 7, I can say those column which is not comes under from type 1 to type 6, we can say type 7. Or particularly if you want to tell, right hand side of the differential equation is, right hand side of the differential equation is for suppose tan x, tan ax, secant ax, cot ax, cosecant ax, okay, then these forms are comes under type 7. So especially I will tell, I can tell the problems which is not comes under type 1 to 6, we can try to solve type number 7, but those problems which I am going to solve in type 7, we will solve the same problem in some other method. That is the name of the method is method of variation of parameters. So that is also in the syllabus. Maybe next week we will discuss method of variation of parameters. The similar type of problem, the problems which solved, which we are going to discuss in type 7, we will solve again using method of variation of parameters. So, okay. So again, I will tell when I will solve method of variation of parameters, I will just tell we solved already in type 7 similar type of problems. Okay. Problem, I will take the problem. Okay. Solve d square plus a square into y equal to secant ax. Okay, solution. So as usual, you should find the complementary function. M square plus a square equal to 0. So this implies m square equal to minus a square. This implies m equal to plus or minus ia. Complementary function is alpha is 0, beta is a. So e power 0x into c1 into cos ax plus c2 into sin ax. So pi equal to 1 by d square plus a square into secant ax. So now you can write this is d plus ia into d minus ia. So d plus ia into d minus ia is d square plus a square into secant ax. Okay. Now I'm going to write this is d plus ia minus d minus ia. So d gets cancelled. Ia plus ia. So 2ia. That's why I'm going to divide by 2ia divided by d plus ia into d minus ia into secant ax. So otherwise you need to use partial fraction. For 1 by d plus ia into d minus ia, you should use partial fraction, that is equal to 1 by d plus ia into d minus ia equal to a by d plus ia plus b by d minus ia, and they should find the values of a and b. You can check it. You can check it. A is A is minus 1 by 2 ia and B is 1 by 2 ia. So you can check it. Okay. So, but I know that this case, if you write like this, you can split the function like this. So that's why I write. But it is not always possible. In those cases, you should split this function using partial fraction. So you should know how to apply partial fraction these cases. Okay, now I'm going to write this is d plus 1 d plus ia divided by the denominator d plus ia gets cancelled 1 by d minus ia. The next step 1 by 2 ia is common, 1 by d minus ia plus minus minus 1 by d plus ia into secant ax. Okay. So up to this step, you can do it. This is actually we are calculating a particular integral. So now I need a result. Okay. So the result is 1 by d minus m into capital X. Capital X is the right hand side of the differential equation, is equal to e power mx into integral e power minus mx into capital X into dx. So this is the result. So how to get this result? Okay, so proof is also I'll give here. But in the examination point of view, proof is not needed. The only thing you should know, this result is enough. Okay, just you should know the proof, how to get 1 by d minus m into capital X is equal to y. This implies cross multiply. I'm taking the left hand side equal to y. D minus m into y equal to capital X, where capital D equal to d by dx. So, and hence dy is what? dy by dx. Minus my equal to capital X. Okay, now this is actually linear differential equation in y. Okay, dy by dx minus my equal to capital X. The solution of this linear differential equation is y into e power integral minus m into dx is equal to integral capital X into, that is a q, okay, integral minus m into dx. So here I am not going to add c because I am going. Actually I am finding particular integral, so that's why I don't add the constant c here. So y into e power minus mx equal to integral capital X into e power minus mx into dx. So from this you can see what is y. Y is e power mx integral capital X e power minus mx dx. So this y is nothing but what? This y is nothing but 1 by d minus m into x. So 1 by d minus m into x is equal to e power mx integral x into e power minus x into dx. Okay. So now I am going to apply this result. Now you, the next step, you are going to tell how to apply. Okay, any one of them.
Sir,
Okay. Yeah, please tell.
sir, in this result, x can be any function of x, sir.
Any function, any function. That is the right hand side of the differential equation.
Okay, sir. Thank you,
Okay.
sir.
Okay. So even you can apply this method for the previous case also. That is up to you. But that is a little bit difficult. That's why I don't apply. This is for general case. Okay. Right hand side of the function. Okay. This is for general case. So it is better to avoid only for these types of problems, because the remaining problems you can obtain easily. So don't use this result for every problem. Okay, Pragadish. Okay, and then I'm going to write. I'm going to write this equation in the next line, next page. So pi equal to 1 by 2ia by 2ia into 1 by d minus ia minus d plus ia 1 by d plus ia into secant ax. Okay, secant ax. Now we should split into like this: 1 by 2 ia common 1 by d minus ia into secant ax minus, I will write this is d minus of minus ia into secant ax. Okay. So now can you now tell how to apply the result? We know that that is 1 by uh, d minus m into x. What if you identify what is m, what is x? Then if you know this result, you can tell. Can you now tell?
1 by 2ia into
Hmm.
1 by d minus ia.
Okay.
No, sir. E into
E power.
e to the power iax
Okay.
integral of e to the
Ah.
power minus iax
Okay.
into secant ax dx.
Okay. Good. Next, minus.
E to the power minus iax
Okay.
integral of e to the power iax into secant ax dx.
Okay. Correct, Dikshita. Thank you. So in the first case, m equal to ia. The second case, m equal to minus ia. So a capital X is secant ax, secant ax. And if you know this result, just fit what is here, wherever you have m, wherever you have x, just substitute and you can write. Okay. So next step, 1 by 2 ia e power iax. So now integration is a little bit difficult if you keep as it is. That's why I'm going to write this is the cos ax minus I sin ax into secant ax. Then minus e power minus iax integral cos ax plus I sin ax into secant ax. So 1 by 2 ia is common for both the terms. Okay. So now this is equal to 1 by 2 ia e power iax integral cos ax secant ax is 1 minus sin by cos is tan minus e power minus iax integral again cos into secant is 1 plus I into sin divided by cos is tan into dx, close the bracket. So now next step you should integrate. Integration of dx is x. Integration of tan ax is log of secant ax log of secant ax by a. 1 by 2 ia into e power iax into x x minus I log secant ax by a log secant ax divided by a, and then minus e power minus iax into x plus I log secant ax by a, close the bracket. And okay, now this is equal to 1 by 2 ia. We can group these two, and then we can group these two. So if I group these two, if I take x commonly, remaining is e power iax minus e power minus iax. Okay, and then from these two I'm taking commonly minus I log secant ax divided by a. If I take this, you'll get e power iax. Okay, if I take minus commonly, okay, and then here it should be plus e power minus iax. This is equal to 1 by 2 ia into x into. So what is this? E power iax minus e power minus iax.
2 sin IAX.
2 I sin ax. Okay. Thank you for your answer. And this is minus I into log secant ax divided by a. So what is this?
2 cos AX.
Okay, 2 cos ax. What is your name?
Lakshmi Narayan, sir.
Okay. வாய்ஸை வச்சு கண்டுபிடிக்க முடியல இன்னும் என்னால் கூடிய விரைவில் கண்டுபிடிச்சிருவேன். 1 by 2ia, ஓகேவா, மல்டிப்ளை, ஓகேவா, multiply by 2ia, so 2i gets cancelled, x into sin ax by 2i gets cancelled, sin ax by a, ஓகேவா, minus 2i okay gets cancelled, minus 1 by a square cos ax into log of secant ax. I think we got pi here. Okay, pi. So final answer y equal to cf plus pi. So if you have any doubts in the third column, you can ask to me. Solve d square plus 1 into y equal to cosecant x into second column. Solve d square plus 4 into y equal to cot 2x. So try to solve these two columns. So I am planning to take the next section, linear differential equations with the variable coefficients today, but now time is 4:15. So if I take this section, well, you are ready to listen, I know that, but it is better to take coming Friday first hour. Okay, so because this is a new section, so I don't want to introduce this new section okay at the end of the day. Okay, so I will start Friday morning at 8:45. We will discuss this new concept in the early morning for you. Okay, uh, okay, if you have any doubts you can ask to me, otherwise you can leave. Thank you.
Sir,
சொல்லுப்பா லட்சுமிநாராயணன் சொல்லு.
sir, sir, integration of complex number, sir.
Integration of complex numbers.
Sir, we should treat I as constant, sir.
I is constant. I equal to what? Root of minus 1.
Okay, sir.
Okay. You should keep I as it is. I is constant.
Okay,
Any
sir.
other doubt? Okay, thank you. Any other doubt? Okay, then there is no other doubt. We will meet on coming Friday. So try to practice more problems. I don't give any assignment to you, but I'm giving some practice problems this time. So try to solve more problems from the Virarajan book. I also send some other book. Okay, you'll practice problems, and also you have ZIL book and Erwin crazy book. Okay, so you can also refer those two books also. So first I will finish the basic things, and then I will go to the application part. Suppose if you have enough time now, you can also refer some of the application problem. Okay, try to solve some of the application problem. When I am taking the application problem, it is very easy for you that time. Okay, thank you.
Thank you, sir.
Thank you. Thank
Thank
you.
you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Thank you, everyone.
Sir,
சொல்லுங்க.
sir, in the last two, A is any real number.
A is A is any real number. Just AX and
Okay, sir. Yes.
okay. A is any.
Thank you, sir.
Okay. I'm restrict பண்ணல. There is no restriction. Just A.
Okay, sir. Because காம்ப்ளெக்ஸ் நம்பரா இருந்துச்சுன்னா ஐயோட சேர்ந்து திரும்ப ரியல் நம்பர் ஆயிடும்.
இங்க வந்ததுனாவா?
Sir, m is equal to plus or minus I. If it's A is a complex number, then
A காம்ப்ளெக்ஸ் நம்பரா இருந்ததுன்னா plus or minus A. Okay. So A வந்துட்டு suppose for example 1 plus 2i. ஓகே, ஜஸ்ட் ஐ இருந்ததுன்னா அது வந்துட்டு ஐ ஸ்கொயர் இதாகிடும்.
yes,
ஓகேவா?
sir.
ஓகே ஓகேவா? நான் ஓகே அந்த கேஸில் ஆகிடும். பட் இப்போ ஏ வந்து காம்ப்ளெக்ஸ் நம்பராக இருக்குன்னு வச்சுக்கோ.
Yes, sir.
1 plus i. ஓகே, 1 plus i இருக்கும்போது நமக்கு வந்து ஆகிடும். அது எகைன் ஏ காம்ப்ளெக்ஸ் நம்பர் தானே?
Yes, sir. Yes.
பட் வி டோன்ட் நோ, ஏ மேபி எனிதிங். ஸோ நம்ம ஜென்ரலான சொல்கிறோம். காம்ப்ளிமெண்டரி ஃபங்க்ஷன்ஸ் வந்து ஜென்ரலாக வி ஆர் டிஸ்கஸிங் ஜென்ரல். So A may be anything.
Yes, sir. Okay.
Okay, thank you.
Thank you, sir.